What's up, guys? Today's class, we shall be doing this derivations based on a chapter called as work power energy. Now, complete 10th standard stuff, the basic things are there, excluding the numericals. Do not think I'm trying to talk about the 10th standard numericals here. I'm only talking about the theory part of the 10th standard is almost the same in your 11th also. So you learn about work. Again, what's the definition of work? What's the definition of power? What's the definition of energy and all these things. All these definition based questions from this chapter will be maximum for 2 marks, nothing apart from that and nothing more from that. Now, what has to be remembered when you're trying to learn the chapter is there are a few derivations. In fact, there are two very important ones which we'll be solving in today's class. Okay. And both of them will involve one small concept called as collisions. Fine. Now, the good thing or the bad thing that you guys should decide is collision is very easy to understand in terms of logic, because accidents. Let's talk about word accidents. What does the word accident mean? When two or more things collide. Now, if you see the language what I used here, I never told two or three vehicles or one or two vehicles. I always told two or three things. For example, there are a lot of places where a bike or a car goes and hits a stationary object. The stationary object can be a rock, okay, or some sort of, let's say, a wall. Any of these things. Fine. So the word collision always means when both of them, when two or more objects come in contact and there's some kind of change happening there. Okay, that's the meaning of collision. Now, what happens here is in your specific derivation. Again, as I told you, there are two types. No, one is derivation with respect to inelastic collision. Inelastic. The other one is with respect to elastic collisions. Fine. So I'll be doing both of them today. Make sure that you guys watch this and practice them right now. Fine. Because the way, teaching this is very simple. You guys will also learn it very quickly because it's completely simple, but remembering it is where the problem lies. You will always get confused with respect to what the first step was, what the second step is. But the moment you guys remember it, you trying to get the answers will not be such a hectic job. It's going to be very simple. Okay. Now let's talk about the first topic, which says inelastic collision. Now, before this, we're supposed to revise one small concept called as conservation of energy. Okay. I'm not sure which standard we learned it. We always learned this famous statement that energy can neither be created nor be destroyed, but can always be converted from one form to another. That's what we learned about energy. That specific statement can be applicable for a lot of other concepts. One of the examples, nothing but momentum. I'm pretty sure you guys remember what momentum is. Momentum is always represented by the letter P and is given by the formula m into velocity. All right. Okay. M means mass. V means velocity. Now the thing here is we're supposed to talk about conservation of momentum. That's the whole concept as to what both the types of collision depends on. Without knowing the concept of collision, we will not know the concept of, without knowing the concept of momentum, we will not be knowing the concept of collision. Now, the good thing here is what we learned already in your 9th standard is when it comes to velocity, there are two types of velocity. One is represented as U, called as initial velocity. The other one will always be called as final velocity. So think for a second logically. If there are two kinds of velocities, fine. There will also be two kinds of momentums called as initial momentum represented by Pi and final momentum represented by Pf. Okay, so Pi meaning I'm trying to multiply m into initial velocity and Pf meaning I'm trying to multiply m into final velocity. So please be open to the concept of there can be two types of momentum when it comes to a concept in physics. Similarly, since there are two velocities, don't you think when we learned again, because I'm talking about this concept because the chapter's name says work, power and energy. The first thing which comes to our mind when I use the word energy is the conservation of energy statement. The second thing is what kind of energy is being used multiple times in physics. Everybody's answer will be common, called as kinetic energy, given by the formula half m into velocity square. There's a reason as to why I'm not using the letter V. I'm always sticking on to the phrase velocity because, again, in the same chapter, we learned that there are two kinds of velocities called as initial as well as final, which I wrote just now, which means be open to the idea that in this chapter, there can be something called as KE initial, KE final. Okay, be open to all these ideas. So Pi meaning momentum initial, momentum final, KEI meaning kinetic energy initial, kinetic energy final. This is exactly how this chapter works. Now, all these concepts put together, I'll be talking about in one specific concept called as collision. To understand collision, everything, whatever we spoke about right now is important. Now, how will the question be asked based on collision? First thing is the definition, which you guys need not learn in today's class. I'll send a PDF. It is already present there. The derivation is there in the PDF, but this is a much more simpler way to do it. So stick on to this specific method. In fact, a lot of colleges prefer giving marks in this method also. Okay. They might teach some other method, but they prefer giving marks in this method. So what are we trying to derive? We are trying to derive an expression for this concept called as inelastic collision. Again, usually whenever we're trying to derive few stuff, there are few conditions. In this, there are two conditions. Initially, what is happening, then finally, what is happening. Again, careful with the language, what I'm trying to use here. Be careful there. I'm using the word initial, I'm using the word final, which means both the velocities will be used here. That's a hint there. Now, what is the condition? The main condition is just one. Is just that I'm going to take a mass. I'm drawing squares. You can draw any of the shapes. I'm going to take one mass. I'll name it as M. Okay, fine. I'll take two cubes. I'll name it as M1. I'll name it as M2. The condition goes like this. M2 is stationary, which means it is not moving. If something is not moving, it will not have velocity. Correct. So below M2, first thing I'll write is U is equal to 0. I'll write. Can I be more specific here? Why write U? Can I write U2? Because since there are two things, no. That's why I'll write U2. So basically, M2 is nothing but some kind of an object which is not moving. It is settled somewhere. Just example, let's say a boulder. It's not moving anywhere. But M1 is one kind of object which is moving towards M2 like this. Okay. M1 is not stationary, which means it is moving, which means it is going to have some kind of velocity. I'll name the velocity as U1. Is it how much is the value? I don't know. But the thing is, it is not equal to 0. U1 has some kind of value. This is the initial condition. Now, secondary condition is after some point of time. Okay. Again, as I told you, block M1 is moving towards block M2, which means there will be some point of time where both will come into contact. That contact point where both of them where both of them hit each other is called as collision, which looks like this. Oh my God. Okay. Which looks like this. Both the diagrams are important. You're supposed to draw two square blocks touching each other. Okay, that point of contact is very important. So the left diagram is before, the right diagram is after, where they come in contact with each other. Now, once you draw both of these diagrams, I hope you guys understood. Again, guys, M2 is not at all moving. M2 was stuck at one place. M1 moved towards M2 and hit it. Just like a car hitting a boulder. Boulder is not moving, car is moving. Car goes and hits the boulder. The moment it hits the boulder, that is called as inelastic collision. We're supposed to derive that. Now focus. How do we start the derivation? Just like I told you, whenever I use the word energy, the first thing what comes to your mind is conservation of energy. But right now, I'm supposed to, I'll take a phrase of it. I'll use the word conservation. But in this case, we are not trying to conserve energy. We are trying to conserve something called as momentum. So I'll write conservation of momentum. Okay, very important. I hope you guys realize that when I taught you guys this part, I told you momentum is always represented by the letter P. And in this case, be open to the idea that there are two kinds of momentums depending on whatever kind of velocity. Same thing I'm sticking on to. Now, conservation of momentum has to be done based on the diagram and diagram alone. Fine. So the reason I put a dotted line between both the diagram is because whatever is happening to the left-hand side is always represented by U, which means that happened initially. After some point of time, whatever happens, it will be represented by V. Now, so mass 1 after hitting mass 2 will have some kind of velocity. Similarly, mass 2 will also have some kind of velocity. Now, guys, think for a second. If you're not able to come across the boulder example, I'll give you one more example. Just imagine a bike which is being parked on the road. Okay. But a car guy comes and hits the bike. Now, think of initial case. The bike is not moving. The car is moving, which means M2, which is of the bike, is 0. Okay. U2 is 0 of the bike because it's not moving. The car comes with some kind of speed, hits the bike. Once both of them come into contact, don't you think even the bike moves? The bike flies, in fact. Okay. When the bike moved, the bike, I use the word move, which means it is moving with some sort of velocity. That velocity was generated only because of the help of the car. Is it good or bad? I don't care. End of the day, the car hit the bike also moved, and there was some change in the car speed also. It obviously keeps on decreasing because you are at, let's say, 100, you hit something, you'll automatically come to 60 or 70 or 80, depending on whatever impact you had. Okay, so that's the thing. So basically, you're supposed to represent it by V1 and V2, but this is only after the contact has been made. If the contact has been not made, there'll be no change. But in this case, according to my diagram, I've shown that contact has been made. Then I write the heading which says conservation of momentum. Okay, I'll underline that for you. Now, very simple. Left hand side, right hand side. Merge both of them together. That's all. That's the meaning of conservation of momentum, which means left hand side, think. I'm talking about M1, M2 when they are not in contact. This is not in contact. Not in contact. This is in contact. Left hand side always focus on contact. Always focuses on not in contact. Right hand side always focuses on in contact. Now, when they were not in contact, momentum is given by M1U1 plus M2U2. You guys agree with me? I'll tell you how. Because momentum P is equal to M into U. U meaning velocity in this case. How many blocks are there on the left hand side? 2 blocks. So therefore, it will be M1U1. Momentum 1 and M2U2. The word and in physics means what? Obviously, I am trying to add. I added both of them. That is the left hand side is done. Conservation always will have equal to. Same thing, whatever I did for the right and left hand side, I'll do the same thing for the right for the RHS, where the in contact was there. What's the main change? The main change is the velocity is no more u, it became v. So you write mv1 plus my bad guys, m1v1, sorry, m1v1 plus m2v2. What formula? P will be equal to m into v. Why am I changing letters? Because one is initial, the other one is final. That's how things work. Now, if you observe properly, according to my left side, observe properly, I wrote something here. Before moving, one was stationary, no? So u2 is equal to 0. If u2 is equal to 0, don't you think the one which I'm marking right now, that value will completely become 0? Because u2 is 0 and anything multiplied by 0 gives you a 0, which means after substituting, what is left on your LHS? Only M1U1. The M2U2 vanishes, becomes 0. Why? U2 is equal to 0. On the right hand side, think is equal to, don't you think, guys, think for a second. When you push somebody, what happens here is you're actually transferring some sort of energy. Okay, in this case, when the car hit the stationary bike, the moment both of them came in contact, what is actually happening here is there is some kind of shift. Both the velocities will become equal. Remember this, that energy exchange is happening. No, both the velocities will become equal, which means on the right hand side, v1 will be equal to v2. That's like a secret. Okay, remember this. On the right hand side, whenever they come in contact mean, guys, same thing with the handshake. Whenever you shake somebody's hand, if you actually focus properly, you will find some kind of energy exchange happening there. You will feel that their hand is cold or hot or whatever the thing is happening. But end of the day, there is some kind of energy exchange happening here. Here, they can't exchange mass. Car can't tell, hey, I weigh 1 ton, I'll take half my weight and give to the bike. Mass transfer is impossible in that case. So what can it only give? The velocity with which it was traveling in. So the velocity becomes equal. So instead of writing v1 and v2 separately, since they became equal, I'll use the letter just v to represent in contact velocity. Okay, to represent in contact velocity, because both of them are anyways the same. Why use v1 and v2? So automatically on the right hand side, if you see, instead of me using v1, v2, I could have used only v and v. So it becomes m1 into v plus m2 into v, which means, one second guys, m2 into v, which means on the left hand side in the next step, there'll absolutely be 0 changes happening there. But on the right hand side, I can make some small algebra changes, which means I'll take v outside common. After taking v outside common, m1 plus m2 I get. Now, I'll keep the v on the right hand side as it is, shift the m1 plus m2 to the denominator, and it becomes like this, m1 u1 whole thing divided by m1 plus m2. This is my answer for final velocity. Now, if you ask me, this answer is for, I'll mark this to be equation 1. This answer is for which one? V1 or V2? Both are same, which means once they come in contact, some sort of energy exchange is happening. That energy exchange in this case was nothing but velocity, which means both are equal. And since both of them are equal, I found the value of V, and this is my answer. Should you mug it up? Please don't mug it up. Now, I also told you in the chapter work power energy, the first thing you guys come across is the conservation of energy. Therefore, we solved it. I also told you the second thing what we come across is something called as kinetic energy. That's why I thought kinetic energy. Same thing, apply that kinetic energy concept here. But how to apply? Listen, you should not just write kinetic energy. You should write loss of kinetic energy. Loss of kinetic energy. So again, what does the hint say? The hint is very simple. Whenever you come across energy, first you talk about conservation. Talk about that. Second, you talk about kinetic energy. Talk about both of them in the same derivation, and you guys will get full marks. Now, loss meaning minus, always as a minus. So I'll represent delta KE. What is delta meaning? After there's some kind of loss, okay, there'll be some kind of change. Let's say you guys initially had 10,000 rupees, you lost 4,000. How much is left? 6,000. How did I get 6,000? 10,000 minus 4,000. So after losing money, the amount left is called as balance. Here it's called as delta. Okay, the change. So it'll always be KI minus Kf, meaning kinetic energy initial minus kinetic energy final. Can there be two kinetic energy? Yeah, I told you before starting. No, that's how it works. Now, delta Ke is what you guys learned. Ki and Kf formulas are very simple. Now, what does Ki or Kf mean? Same, go to the diagram part. Initially, what happened? Initially is when they were not in contact. Not in contact meaning initial. When they are in contact, it becomes final. So I'm going to apply the same logic here. Fine. So left hand side, delta K, keep it as it is. Ke, I have to write. 1 second. Delta Ke as it is. For the right hand side, careful. Ki meaning, I'm talking about the first diagram where it was not in contact. But end of the day, we always know the formula for kinetic energy given by half mv square. So I'll write half m1 u1 square. How u1? I'm talking about the left hand side diagram. m1 u1 plus, because there were two diagrams, I'll put a plus, half m2 u2 square. That's all. So because there were two diagrams on the right hand side also, I mean on the left hand side, I spoke about both of them. And there was a minus here. I copy paste the same minus here as well. I'll open one more bracket. Now Kf, it says Kf meaning final kinetic energy, which means I'm supposed to talk about the diagram on the right hand side. What's the only change? All the u's become v's. That's the change. I'll shift here also. So it'll become half m1. Guys, think carefully. Can I, instead of using v1 and v2, because both of them are same, we assume something. I'll only write it as v on the right hand side because both of them will be same after they clash. So it'll be half m1 v square plus half m2 v square. Same velocity of m2 v square. That's it. This is called framing the diagram, framing the equation. Now, obviously, everybody knows the value of u2 is equal to 0. Automatically, the second term becomes 0, as everybody knows. Now, the left-hand side, I'll write it as delta k because there's no space. What is left after cancelling that 0 part? In the first bracket, half m1 u1 square is left. Minus, careful guys, okay, minus, I'll open bracket again. Inside the bracket, you can again find v square to be common. So what I'm going to do, I'll write half m1 in brackets. Oh, okay, do one thing. There are two things which are common, in fact. I won't confuse you. Half is common in both the places, as well as v square is common in both the places. I'll take both of them common. So I'll take half v square common. After taking common, m1 plus m2 is left. Okay, after taking common, m1 plus m2 is left. Now, delta k is equal to half m1 u1 square minus, open brackets, half. Instead of writing v, now careful. We found the answer for v in the equation 1. Correct. I copy paste that. What's the answer? m1 u1 by m1 plus m2. I'll open brackets. m1 u1 by m1 plus m2. Since it had a square on top of it, I'll put a square also on top of it. Same thing. Now here, inside the bracket, m1 plus m2 was already there. Okay. This is my answer. Now, what can be done? Common sense is, can't I cancel this m1 and this m1, m2? Square is there, no? So out of square, one part gets cancelled because the square here belongs to both the denominator as well as the numerator. Little logic I apply, I used, that's all. Now continue. Delta k is equal to half m1 u1 square. Okay. Minus, what and all is remaining? I'll write properly, careful. Half is remaining. The m1 u1 square is remaining. m1 u1 square is nothing but m1 square into u1 square. Whole thing divided by m1 plus m2. Now, please don't ask me a question, sir, we cancelled it. No, we cancelled only one of it. Okay, we only cancelled what? One of it. That's all. Okay, so all these things were remaining. A plus was remaining there. I forgot. Okay, now what can be done? Now, everything got cancelled. This is almost my last step. Carefully check. Again, there are two parts, and in both the parts, I can find something common. Okay, so guys, the logic part is done. I'm just trying to do algebra right now. So delta k will remain as it is. Half, I'll take common because I can see half in both the places. I can also see m1 in both the places. I can also see u1 in both the places. Okay. In fact, I can see u1 square in both the places. Observe properly. u1 square is here. u1 square is here also. Fine. So little logic I used. I wrote half m1 u1 square carefully outside. After taking it outside, in the first term, what and all is left? 1 is left because everything got used up. Minus. Half I took outside anyways. M1 will be left in the second term divided by M1 plus M2. Okay, divided by M1 plus M2. Now, delta K on the left-hand side is as it is equal to half into M1 U1 square. Take LCM inside the bracket. Inside the bracket meaning it will be M1 plus M2 is the LCM. M1 plus M2 is the LCM. Crisscross. It will become M1 plus M2 minus M1. Regular algebra here. Cancel off M1 and M1. So delta K is equal to half into M1 U1 square remains as it is, open bracket. Whatever is remaining, copy paste that carefully. M2 divided by M1 plus M2. This is your final answer for inelastic collision. Okay. Again, as I told you, as the beginning of it, please watch this again. If you didn't understand, again, I want you guys to practice it. For sure, 5 marker, either this or elastic. Again, just like redox reaction, we'll have to, we should not do both the things in the same day. Now see what I'm about to tell you. Careful. Inelastic is done. One of this only will come, I realize. Okay. Elastic will do in the, we'll do tomorrow. Because tomorrow is a Thursday. Yeah, tomorrow is the Thursday, August 22nd. Cool. So, inelastic, we are done today. Practice this. Don't forget, practice this. Now, below this, I would have sent the notes also. Along with this, sorry, not below this. Along with this, I would have sent the notes also. Make sure you guys learn all these small definitions. There are few places where you guys will get confused. Work under variable force. All those things skip. Not required. Okay. In the PDF, whatever I sent you, there are few places which are very, very, very easy. For example, they are essential also. Definitions I'm talking about. You'll come across power. Okay. You'll come across the energy. You'll come across work, along with examples where work is equal to 0. Same example of 10th standard. Revise all these things. Okay. Revise all these things. Don't try to, ignore this. These will be asked. It's just that we don't be asked as a 5 marker. Fine. Conservation of momentum also will come across. Don't learn that. Learn this only, because whatever I taught you here, this is exactly what is being spoken about there. Conservation of momentum. Don't learn the derivation is what I told you. Learn the definition. Okay. Learn the definition there. Derivation is anyways here. Batch it off. Please, once you finish this, even though in the in the PDF, you guys come across elastic collision. Don't even see that. Don't even see it. Ignore whatever elastic, because tomorrow's class will do it. Fine. Today's class only focus on one, and which is nothing but inelastic collision. Fine. Nothing else has to be learned from this chapter. Make sure you guys practice this one twice. Just like redox. This is very important. Fine. I'll see you in the next class.